So on this lesson today, we are solving absolute value equations. There is a three-step process that we need to go through, and I'm going to do it out loud. Eventually, as we go through this, you should be doing this in your head, like as we go through it, right? So you see this equation right here and this equation right here are completely different. If they wanted it to say x equals 4, they would have wrote it that way, but doesn't it have those weird bars with it, right? So how to solve an absolute value equation? Step 1, we have to get the bars all by themselves on one side of the equal sign. I'm going to jump over to 3 for a second. Do you see number 3? I could care less what's inside the bars. I'm going to black that out with like a green blob right there. Do you see? These are the bars. They are not all by themselves on one side of the equal sign. Isn't there a +2 hanging out with them in that case? So step 1 is to get the bars all by themselves. They are. Would you believe that these bars are all by themselves on one side of the equal sign? So boom. Step 2, common sense check. I'll talk about that in a minute. We'll come back to that, right? We'll do a common sense check. But step 3, we're just going to solve this equation. And I made the first one way too easy, because you should be able to look at that and know what I could put in for x to make that true. What could I put in for x to make that true? Absolute value of what is going to give me 4 back? 4 is a definite. Is there anything else? Could you put any other number in there, and if you made it positive, it would turn out to be 4? 4 or what else? -4. Are you with it? Isn't there more than one answer to this? So what we do is this step 3. We're going to take what's in the bars, or you call it x is in the bars, right? We're going to take what's in the bars and set it equal to what you see right here. Boom. 4. Then you're going to have to do a whole new step and take what's in the bars, that's x, and set it equal to the opposite of this guy. Who is the opposite of 4? -4. And then you would solve each one of these for x. You're going to have to solve 2 equations today. The dumb thing is, this is already done. Like, there is no solving for x. Doesn't it say x equals 4 or x equals -4, right? So it's going to take a little getting used to here, but as we go through it, I'll bet we'll get more comfortable. So here we go. I'm going to talk you through the whole thing. Step 1 is isolate the bars. My thing is, are the bars all by themselves on one side of the equal sign? You can't see what's in there. Don't look in the bars. Are the bars by themselves? Yes. Would you believe that that blue blob right there, you see the blue blob inside of there? If it was 9, would this be true? Yes or no? If that blue thing was 9, like if I put 9 in here, would that be true? Yes or no? Is absolute value of 9 turn out to be 9? What else could I put in there instead? That's what we're going to do next. We're going to take what's in the bars and make him 9. Or we're going to take what's in the bars and make him -9. Cool? So we're going to just kind of do this. What's in the bars? X plus 3. There are no absolute value bars in the 2 equations that we're going to write. We're going to say he's 9. Or we take what's in the bars and we're going to make him -9. And I want to slow down for 1 second. Isn't that literally what you said? This could be 9, or that could be -9. And isn't that right here? X plus 3 could turn out to be 9, or x plus 3 could turn out to be -9. That would make a true statement. So our job is to solve each one of these. And I'm totally fine if we skip baby steps. How do you get x all by itself here? Subtract 3. Well, it's 9 minus 3, baby. 6. Or, what would I do when I solve for this one? What's my moves? It's still subtract 3, right? What's -9? Take away 3, baby. -12, right? -12. So it's not like those 2 numbers are going to be the same. So watch this. We're supposed to check these to see if we get extraneous answers. That's more of an algebra 2 thing. But check this out. If I put 6 in here, what's 6 plus 3? And I take the absolute value. Do I get 9 back? Yep. If I put -12 in there, what's -12 plus 3? It's -9. But when you take its absolute value, do you get 9 back in that case? So there's 2 answers to this guy. How will you type them in on homework? You will separate them with a comma, right? You do not put them in parentheses or anything like that. You'll type 6, -12. What order do you put them in? It doesn't matter. I don't need you to write those out. We're just going to solve our 2 equations like this. But what we have not talked about yet is step 2, the common sense check. I'm going to ask you this. Before we do number 3, talk about that with a neighbor. I don't need to do any work to figure that out. Here we roll. We will now start number 3. Are the bars all by themselves? Yes or no? Nope. I need to move this +2 to the other side. How do I move it to the other side? Subtract. The bars got to stay. We can't get rid of the bars until we get them isolated. So how do you feel about x, absolute value of x minus 5 equaling 18? Cool? So we have isolated the bars. It is time for a common sense check. Check that number right there to see that it is positive. Is that a positive number? Yes. If it was negative, we would stop and say no solutions to this, right? But it is positive, so we must continue on to step 3. Now we set up 2 equations. Take what's in the bars, set it equal to what you see. I saw 18. Or take what's in the bars and set it equal to the opposite of it. So this never changes. That never changed. The only thing that changes is in these pink boxes. One time it's 18, the other time it's negative 18. Solve each equation for x. So my move is to add 5 to both sides, and I get 23 right here. And my other move is to add 5. Both times you're going to do the same move, right? Because it's x minus 5 both times. I just got to add 5 to this, and I will get negative what? Negative 13. And if I substituted those back in, it's going to check. The only time for us it won't check is if this number over here is negative. When you get to advanced algebra 2, they start putting x's on the outside of that, and you got a whole different ball game, but that's in a couple of years. Are you with me? For now, if it's just a number, the only thing you care about is it's positive. I should say it better. It can't be negative. It can't be a negative number. So let's try again. Ready on 4? Let's talk through it. Again, this is what your brain has to do through the test. Are the bars by themselves? Yes or no? Nope. Here's a weird fact. You can't distribute into absolute value bars. It doesn't work. You can only distribute into parentheses. I won't lie. Sometimes it works, sometimes it doesn't work. We're going to say that it doesn't work. You can't do this. You with me on that? You can't do that. So I need to get this out of the way. Is this a +4 or a ×4? What is that? That's a ×4. I need to get rid of it. How do you get rid of a ×4? We're going to divide both sides by 4. So that's going to be this. If you need to show the baby step for yourself, that's not a bad idea. You're dividing both sides by 4 in that case. Cool? So I got rid of that ×4. I'm going to re-talk myself through it. Are the bars by themselves? Yes. Common sense. Is that not negative? The reason why I say that is because it could also be 0. 0 is okay, right? It got to be positive or 0. It can't be negative. Rock and roll? So, cool. Set up 2 equations. Take what's in the bars, set it equal to what you see. So 3x minus 6 is in the bars. I'm going to set it equal to 7. Or take what's in the bars, that never changes, and set it equal to the opposite over there. It could be negative 7. And one last time, I'm just going to show you why this is happening. True or false, if this red blob was 7, I'd have a true statement. If I put a 7 right there, does that come out true? Is the absolute value of 7 turn out to be 7? That's why I said that's what this is. It could be 7, or it could be negative 7 in that case. Rock on? So, all right. Let's solve for x. And they ain't coming out very nice on this one. That's going to be all right. I don't want decimals. I want fractions. So I'm going to add 6 to both sides. And that ain't going to come out nice, so I'll divide by 3. If you need to show a baby step, it doesn't hurt my feelings, but I need to look at this as a fraction and see if it can reduce. Does 13 over 3 reduce at all? So we're leaving it 13 over 3. Cool. Solve the other one for x. So I'll add 6 to both sides, and then I'll divide by 3. And that'll happen a lot, that they come out to be nasty little fraction boys. You feel okay with that? So this ain't my first rodeo either. I know as soon as I stop talking people through it, a lot of people will struggle. That's normal. What I want you to believe is you should talk yourself through this. So I'll start all over on this one. Are the bars by themselves? Nope. What's your move to get them by themselves? Subtract 11. All right, let's subtract 11 from both sides. The bars are still there though, right? We don't lose the bars until after step 2. Step 2 is the common sense check, correct? What we're looking for is this number here to not be negative. It is negative. That's bad. Are you with me? That's bad. But it's awesome for us because we don't have to do any work. How many solutions will this have? No solutions, right? So no solutions. No solutions. Did not pass the common sense check because absolute value of something has to come out to be either 0 or positive. It can't be negative. Cool? So last one of these, I think, maybe, check this out. I'm going to just do this. I'm going to black this whole thing out just for fun and call it X. Just pretending that was X. I would like to get that by itself. This is what we did a couple chapters ago. What's your first move to get X by itself? Would you divide everything by this negative, or would you subtract 3 first? What would be your first move? We want to subtract 3 first, right? Let's do that first. We shall subtract 3, but the bars are there, right? So we'll do that. So it's the negative absolute value of X plus 7 equals 12. I cannot do a common sense check yet because the bars are not by themselves. You have to get the bars by themselves before you do common sense. There is a -1 outside of the parentheses, outside of the bars. Can I distribute it through there? Yes or no? You cannot do that. So I need to get rid of it. Is this a times -1 or like a subtract 1? What do you think? It is a times -1. So we will get rid of that by dividing by -1. Would you and a neighbor continue to solve this after you have divided by -1? You see, it is now fair to do the common sense check because the bars are by themselves. Does this pass common sense? No. No solutions. Weird, right? Absolute value. But that's because your guess could be high for the number of gumballs or low for the number of gumballs like we did on the activity. That's what the absolute value does. It gives you the positive side or the negative side, but either which way, the number of gumballs is never negative. You know, it's like it's got to be a positive amount. So let's learn how to graph these guys. Again, the copies didn't come off worth a darn for the grid. Here's what I need from you, a little help on this is the generic formula for an absolute value function. Notice they're using f of x because it will be a function. When we graph this, it'll pass the vertical line test. And here, there's 3 little nuggets in there that we're going to get really good at this year. A, H, and K. They ain't going away. They're going to come up in absolute value, guys. They're going to come up in quadratics. We're going to do them with cubics, right? There's all kinds of things about A, H, and K. Can you see in this particular function, here's the bars, right? So this is an absolute value graph. A is the number in front of the bars. Are you with me on that? H is inside the bars, and what's weird is he's got a minus in front of him. And then K is a number being added or subtracted on the outside of the bars. So let's just see, we'll kind of dive in if we can identify them. A, the number in front of the bars. If you don't see a number, guess what it really is? It's not quite 0, it would be 1. Just like if you had the letter X, isn't there really a 1 in front of it, right? So are we kind of down with the fact that there was a 1 there? Cool? Here's the only weird guy, H. H is this dude, kind of. Because you see in this formula, he's got a minus in front of him, which really means opposite. Right? Take the opposite of it. Don't you see a -4 right here? So guess what H has to be? The opposite of that, which is what? positive 4. And what this h value is known as is kind of as an ordered pair. He's the x value of this thing called the vertex, which I'll show you in a second. But k is the normal dude. You see in the generic formula there's a plus in front of it. That means what you see is what you get, right? If you see a +2, you're getting a +2. If you see a -2, you're getting a -2. What you see is what you get, so k is 2. Are you with me on that? And then back to our activity. Do you remember it makes a V shape? That pointy part at the bottom is called the vertex of this guy. It is at this ordered pair, h comma k, where this is the x value of the vertex and this is the y value of the vertex. So could we plot the point 4, 2? 4, 2. Bing. On homework, when you graph these, you have to plot that part first. That's the first thing you have to graph is the vertex. So you're going to plot that. Cool? Then on paper, here's the cool thing. This a value is kind of like a slope. It says it right here for you. It's kind of like a slope. So I'm going to start at the vertex, start at this point, and you see how my a value is 1, which as a fraction is like 1 over 1. I'm going to rise 1, run 1. Rise 1, run 1. Rise 1, run 1. But what's weird is that's only half the v. Like remember, absolute value is going to make a V shape. So what you then do is you use symmetry, or you could kind of do the opposite. It's like rise 1, run 1, like negative. You do these other 3 points. You go like up 1 to the left 1, up 1 to the left 1, and it makes the V shape. Or it's like being off on gumball guesses. If one person was 1 above, this one's 1 below. Like there's symmetry. If I draw my V, there's symmetry through this. Isn't everything on the left side of the V a mirror image of everything on the right side of the V in that case? So please don't draw that green thing. Only draw the blue absolute value guy. Cool? And then the last topic before we do the other ones, please don't work too far ahead of me. How does this V open? Up or down? How does the V open? Yeah, that V opens up. You could have been known that about your a value. If your a value is a positive number, the V will always open up. If the a value is a negative number, it's going to open down in that case, right? So these are things that are not going away, right? We're just starting with absolute value, guys. So let's see if we can identify. Right here is the a value. It's the number in front of the bars. What would you put? -1. Right now, I know, because I'm experienced, this V is going to open down. Are you with me? That's a negative a value, so the V is going to go down. Cool? H is right here. He's strange opposite boy. That says +1. What do we want? -1. And K, what you see is what you get right there. That is a -6. I'm going to put a -6. And our vertex is always at the ordered pair H comma K. So you'll plot that first on homework. -1, -6. I hope visually you'll get trained, because it's new. You're still new at this, but I know the V is going to go down from there, right? It's going to go down. I need to use A as a slope, so I'm going to go down 1 to the right 1. And on homework, that's the only other point you'd have to graph. You do the vertex first, then you go down 1 to the right 1. It'll make the rest of the V for you on the homework program. But here on paper, you got to do it a few more times. So go down 1 to the right 1, down 1 to the right 1. And then you got to go do the symmetrical points around the vertex. So it's like down 1 to the left 1, down 1 to the left 1, down 1 to the left 1. But knowing that pointy vertexy guy is very important. And then always use a straight edge to connect those dudes together. Absolute value graphs make a V. This bad boy opened down because the a value was negative. Feeling all right? A little head nod? Feeling all right? Okay, let's try another one. Tell your neighbor who A is. -1/4. Tell your neighbor if this absolute value V opens up or opens down based off that. Down. Cool? Weird boy is H. He's the number being added or subtracted to X in the bars, which there is nothing. So what do you think the H value is? Yes, in this case he is a 0 because it's the same thing as saying like absolute value of x plus 0. Like, because it's supposed to be added or subtracted, it can't be a 1, otherwise you'd see it, right? The 1's not there when it's a multiplication situation. So h is 0, and what would you like for k? 7 or negative 7? 7. Plot the vertex first. 0, 7. 0, 7. And then use your a value like a slope. Go down 1 to the right 4. Down 1 to the right 4. Down 1 to the right 4. Can't get a fourth one on there, right? But then I got to do the opposite to do symmetry. So I'm going to go down 1 to the left 4. Down 1 to the left 4. And make my V. Weird looking. I'm going to preview something that you will definitely appreciate another day. That V doesn't look like the other V's. Did he get fatter or skinnier? He got fatter, right? That's called vertically compressed. We'll learn that another day. But that got vertically compressed by a factor of 4. Well, he got fatter. Why? Because this a value was not 1 or negative 1. Are you with me on that? He got different. One more, baby. You and the neighbor, see what you can do on that guy. See if you can get A, H, and K. Check them with mine. And then graph this dude. Check them with mine. See what you think. A is the number in front of the bars. H is the number inside the bars being added or subtracted to X. Opposite boy. And K is the number being added or subtracted off to the side. There is nothing happening there, so that would be a 0 in this case. Plot the vertex first, 5, 0. Rise 2, run 3. Rise 2, run 3. Put as many as you can on paper, up to like 3 or 4. And I ran out of room going to the right. I got off a little bit there, but that's okay. Fix it right there. How could you have how could you have known without ever graphing this that that's going to be an absolute value V that opens up? Because A is positive. Soon we will have a test without a calculator about what all these graphs should look like. Can you see all of them up on the wall up there? We're going to do this to almost all of those graphs, right? And you should be able to know what they look like without ever using a graphing calculator, because I'm going to train you. Why did this one look like a V? Because of these. What are those called? That's what all absolute value graphs look like. They look like V's. Cool? All right, let's do some homework.